Welcome to the class, students. In this class, I will discuss a theorem on image set. So this is the result we are proving. To understand this, first let me define image set. If f is a function defined from a to b and a1 is a subset of a, then image set of a1 is denoted by f of a1. Okay, if this is a1, f of a1 is subset of b. Okay, it draws elements from set b. So it is given by an element b belongs to set b such that b is image of some element a taken from the set a1. So and I can just for problem purpose, so I can just rewrite like this. We claim that an element b belongs to f of a1 provided b equal to f of a for a belongs to a1. Let me repeat. An element b belongs to f of a1 refers to b equal to f of a for a belongs to a1. It is b is an element of f of a1 means b is image of some element taken from a1. That is what I have written here. And these two are interconvertible. From here I can write this one, and from this one I can write this. Okay, now let me have a look at this result. F is a function from a to b and a1 and a2 are subsets of a. We need to prove this following four results. Result number 1. It says that a1 is subset of a2 implies f of a1 is subset of f of a2. So given a1 is subset of a2, here need to prove that f of a1 is subset of f of a2. Okay, it's a very simple result. I need to prove this set is subset of this set. So we know the idea of subset. We need to show that an arbitrary element belongs to f of a1 is also part of f of a2. Okay, let me consider, let x belongs to f of a1. Let me consider one element from f of a1. What the definition says, it says x is an image of some element a for a belongs to a1. X equal to f of a for a belongs to a1. But what is known to us? But a1 is subset of a2. But a1 is subset of a2. So this says x equal to f of a for a belongs to a2. Okay, x is equal to f of a for a belongs to a2. This says that x is present in the image set of a2 from this one. B equal to f of a for a belongs to a2 means b should present in the image set of a2. That's what I have written here. X equal to f of a for a belongs to a2 means x is an element present in image set of a2. Okay, so that proves an element belongs to f of a1 is also an element of f of a2. So therefore f of a1 is subset of f of a2. See how simple it is. Okay, now have a look at the second result. Result number 2. So we need to prove these two are equal. So we need to prove two sets are equal. So what is the meaning of that? So it says that here we need to prove these two are subsets of each other. That is f of a1 union a2 is subset of f of a1 union f of a2. This is result number 1. And the result number 2 is f of a1 union f of a2 is subset of f of a1 union a2. Okay, these two results together proves this equality. Now let me consider an element from this set and prove it is subset of this set. Okay, so let me prove the first one. So consider an element b belongs to f of a1 union a2. What does it implies? This says that the role of A1 is played by A1 union A2 now. So B belongs to f of A1 union A2 means B equal to f of A for A belongs to A1. The role of A1 is played by what? A1 union A2. Okay, that's fine. B equal to f of A. Good. For A belongs to A1 union A2. What is the meaning of this? For A belongs to A1 or A belongs to A2. So what does this implies? See, we are saying B is an image of A for A belongs to A1 or B is an image of A for A belongs to A2. I don't know whether this A is present in A1 or A2, but B is image of that element for sure. Now have a look at this expression. What does it say? This says that B is present in image set of A1 because B is image of some element A present in A1. So B is an image of some element present in A2, that says B is also an element of, or B may be an element of f of A2. So this implies B is an element of this set, or this set means B is definitely present in the union of these two sets, f of A1 union f of A2. Okay, that proves the first result, that is f of A1 union A2 is subset of f of A1 union f of A2. That's good, so simple. Second result is, so a second part of this is, now consider an element from this set. Consider B belongs to f of A1 union f of A2. Here I have not used logical equivalence. Instead of that I am proving it explicitly. I will show you the reason. So this implies B belongs to f of A1 or B belongs to f of A2. So what is the meaning of B belongs to f of A1? B belongs to f of A1 means B is image of some element present in A1. So this says B is equal to f of A1 for A1 belongs to A1, or B belongs to f of A2 means B equal to f of A2 for A2 belongs to A2. Because I don't know whether this B is part of this set, or I don't know whether this B is image of the same element. So I don't know whether A1 and A2 is there any connection between A1 and A2. So there is a chance that B is image of some element present in A1 and B is image of some other element present in A2 as well. Okay, so if that is the case, so this says that B is image of A1 as well as A2 for A1 belongs to A1 or A2 belongs to A2. A1 is present in A1 or A1 is present in A2. A2 is present in A2. So which means B equal to, I don't know whether A1 and A2 are same or different, but definitely I can write that. So B is equal to f of A1 equal to f of A2 for A1 A2 belongs to the union. There is no ambiguity in it. If A1 is present in A1 and A2 is present in A2, I don't know whether A1 and A2 are same or different. But irrespective of the case, union definitely contains A1 and A2. So if that is the case, so B becomes what? B becomes an image of an element that present in the union. So B belongs to f of A1 union A2. So that proves f of A1 union f of A2 is subset of f of A1 union E2. See how simple it is. Now let me prove the result number 3. What the result number 3 says, f of A1 intersection A2 is subset of f of A1 intersection f of A2. Okay, to prove this one, I need to consider an element from here, show that element is also an element of this set. That's all. Okay, let B belongs to f of a1 intersection a2. This implies what? This implies b equal to image of some element a for a belongs to a1 intersection a2. So this says b equal to f of a for a is an element of a1 and also it's an element of a2. So this says b equal to f of a for a belongs to a1 and b is equal to f of a for a belongs to a2 as well. So this implies b, that is b is image of some element present in a1, that says b belongs to f of a1, and b is image of some element present in a2, that says b also belongs to f of a2. That proves b is present in the intersection of these two sets. See how simple it is. Okay, so b belongs to f of a1 intersection f of a2. But converse of this result is not true. That's why they have not given the equality here. They have given just subset. Equality is given along with this one condition. So why this condition is required? So what is it that something wrong which is happening here? Let me just check that. Okay, so converse need not be true. Converse need not be true. Okay, let me consider a simple example which says the converse is not true. I have set A, set B. Let me consider two subsets. Okay, so let this be set A and this is my set B. And let me consider a few elements in this set: A, B, C, D, E. Let me consider F here. And this set contains 1, 2, 3, 4, 5, 6, and 7. Okay, this is my function f defined from A to B. Let me set the images like this. So I'm setting the images in such a way that this condition is satisfied but the converse is not true. Okay, I need to give the example of that kind because I just need to show that. Okay, so image of B. Let me just make image of B is equal to 4 and image of E is equal to 4 and image of C is 2, image of D is 3 and image of F is 5. Okay, so this is the range of this function. That's good. So I'm interested in the image sets. So this is my A1. So this is my set A2. If you want, you can just check this result as well. You can show that this is true. The result number 2 is true for any two arbitrary sets A1 and A2 you take from the set A. You can show it is true. But what happens here? What is the contradiction that we can expect here? Let me just check out that. In this example, if I consider A1, it contains what? B, C, and D. So A2 elements are C, D, and E. So A1 intersection A2 that contains elements C and D. Okay, so these are the elements of A1 intersection A2. So now let me consider F of A1 intersection A2. F of A1 intersection A2 contains what? 2 and 3 as its image. So now let me consider F of A1 So f of a1 is nothing but what? Images of elements present in a1. So it is 4, 2, 3. So it is 2, 3, 4. Let me consider f of a2. C, D, E. So the images are again 2, 3 and 4. So f of a1 intersection f of a2 is equal to 2, 3, 4. You can see the connection between these two now. So it is clearly showing that f of a1 intersection a2 is subset of f of a1 intersection f of a2. This happened because of this one number 4. Okay, look at this number 4, how I have chosen. So you need not to take the same example. You can go with your own example, that is fine. But try to understand how I have chosen 4. Okay, so I have chosen 4 from B in such a way that, so 4 is image of B which is present in A1 alone. Okay, B is present in A1 alone. And I have chosen element from A2 which is present in A2 alone. But I have made the image of these two elements same. Okay, in this kind of situation we can note that an element belongs to codomain has got the two pre-images. So, and that too, how they are present. So, B is present exclusively in A1 here, E is present exclusively in A2. So, in this kind of situation, this arises. So, we can find these two elements which are present in f of a1 and f of a2, that gives that 4 is present here, whereas since B and E are not part of the intersection, so definitely that 4 is not going to come and sit here. As a result, so this is always true. You just take any example, you can always show this result is true. But converse need not be true. Okay, result number 4 says f of a1 intersection a2 becomes same as f of a1 intersection f of a2 if f is 1 to 1. See, if f is 1 to 1, I cannot consider 4 is the image of two elements taken from the domain. So if that is the case, you can definitely show that these two are exactly the same. Okay, these two are exactly the same. Let me prove that through this. Okay, so first part is, so prove f of a1 intersection a2 is subset of f of a1 intersection f of a2. So we just now proved this in the previous result. As you just write on the same result here. Okay, so which I wrote here, the result which we have written here. So that result is valid. So you write that result here. I will just prove the second part of it. Okay, in the second part, what is there? So given f is 1 to 1. Okay, f from a to b is 1 to 1. And to prove that, prove the converse part of it, that's f of a1 intersection f of a2 is also subset of f of a1 intersection a2. Now to prove this, what should be done? Consider an element from here. So consider an element B belongs to f of a1 intersection f of a2. So this says B is equal to, okay, sorry, B belongs to, because it is present in the intersection, means B belongs to f of a1 and B belongs to f of a2. This says B is image of some element a1 taken from set a1, and this says B is image of an element a2 taken from the set a2. So this says B is image of two elements A1 and A2. For A1 belongs to A1 and A2 belongs to A2. So this is what the situation is. So B is the role of B is played by 4. At the two pre-images are A1 and A2. So A1 is present in A1 and A2 is present in A2. So that's what we have written. This says B equal to f of A for A belongs to A1 and A belongs to A2. What is the reason? Because f is one-to-one function. If f is one-to-one function, f of A1 equal to f of A2 implies what? A1 is equal to A2. Because f of A1 equal to f of A2 implies A1 is equal to A2. And I have just written it as A in this case. Okay, so this says B equal to f of A for A belongs to A1 intersection A2. A is common element here. So please observe this carefully. This happened because f is one-to-one function. So we just cannot have this situation. This is what I am telling. We cannot have the situation of a single element of the codomain has got the pre-image. So as a result, this situation will go off. E1 and A2 are two different elements will go off. E1 and A2 are not two different elements. They are exactly the same because their images are same. So if so, A is part of the intersection. So if that is the case, so BE belongs to image set of A1 intersection A2 because B is image of some element A belongs to the intersection. So that says f of A1 intersection f of A2 is subset of f of A1 intersection A2 and is valid only when f is one-to-one function. Now let me discuss a result on pre-image set. So how do we define this? If f is a function from A to B and B1 is subset of B, then pre-image set of B1 is denoted by f bar minus 1 of B1 and is defined by f bar minus 1 of B1. This refers to pre-image set of B1 that is equal to an element from set A such that f of x is present in B1. We have seen even problems on this, so I think by this time you people are comfortable with that definition. So first let me just visualize once again. So before getting into that, this is my set A, this is my set B, and here we have our B1 and pre-image set of B1 will be present here. Okay, this is my f bar minus 1 of B1, this is my B1, and this is the set A and this is set B, and f is the function defined from set A to B. So what we are saying here, x is an element of f bar minus 1 B1 provided f of x is present in B1. That's good. Okay, so and in simple words, so we say x belongs to pre-image set of B1, x belongs to pre-image set of B1 provided f of x belongs to B1. And converse is also true. If f of x belongs to B1, we say x belongs to pre-image set of B1. So these two are equivalent statements. We are making use of them to prove these results. Let me consider this result. This is a question paper problem again, very important one. What does it says? F is a function defined from A to B. B1 and B2 are subsets of B. Then prove the following. First one. So things are very simple here and very important from the point of examination. Okay, I need to prove these two sets are equal. It's so simple. So consider an element x belongs to, okay, x belongs to this set, preimage set of B1 union B2. What the definition says, f of x belongs to, this says f of x belongs to B1 union B2. So this implies f of x is present in B1 or f of x present in B2. So f of x present in B1, from the definition it says x belongs to preimage set of B1 or x belongs to preimage set of B2. X is present in any one of these two sets. I don't know where it is present, but definitely it is present in the union. See how simple it is. And for the converse part of it, I need not to prove it separately. I can just prove it here itself. So x belongs to preimage set of B1 union preimage set of B2 means x is present in this set or in this set. Now x is present in preimage set of B1 means f of x is present in B1 or f of x belongs to preimage set of B2 means f of x belongs to B2. So f of x is present in B1 or B2 means f of x is present in the union. If f of x is present in this union, definitely x is present in the preimage set of B1 union B2. See how simple it is. Now let me prove the second result now. It works in the same lines. That x belongs to preimage set of B1 intersection B2. So this proves f of x belongs to B1 intersection B2. So this proves f of x is present in B1 and also in B2. So f of x is present in B1 means x belongs to preimage set of B1. It is also present in preimage set of B2. That means x is a common element. So that's why we are writing it in the intersection. For the converse, I can just use the logical equivalence again. X belongs to this set means x belongs to this set and also in this set. So x belongs to this set refers to f of x belongs to B1 and f of x belongs to B2. Now f of x is present in B1 and also in B2 means f of x is present in the intersection. If f of x is present in the intersection, definitely x is present in what? Preimage set of B1 intersection B2. That proves the second result. See, so simple. Third one, you can easily do it from yourself by this time. It is what? Once again, equality of sets. Let me consider an element x belongs to preimage set of B1 bar. So this proves f of x belongs to B1 bar. If f of x is present in B1 bar, definitely f of x does not belongs to B1. If f of x does not belongs to B1, definitely x does not belongs to preimage set of B1. If x does not belongs to preimage set of B1, definitely x is part of its complement. See how simple it is. Okay, that proves this is subset of this. For the converse, what I need to do, I need to consider an element from here. So x belongs to this set, which means definitely x doesn't belongs to f power minus 1 of B1. So x doesn't belongs to this means definitely f of x doesn't belongs to B1. F of x doesn't belongs to B1 means definitely f of x is part of B1 complement. F of x is part of B1 complement means definitely x is present in the preimage set of B1 complement. That's all. See how simple it is. Okay, so please go through these results, and if you have any doubts, so please come back. So thank you all.